Hey everyone, we are going to do our quick video for Unit 2, Lesson 13, where we talk about proofs involving parallelograms. So first, we just want to talk about, kind of briefly, like what makes a parallelogram and what other properties kind of fall under it. All right, so you can read these here also, but the main thing about a parallelogram is that opposite sides are parallel to each other and opposite sides are equal in length, right? So we can see the mark of sides being parallel. So again, you see opposite sides. So think of left side, right side, top side, bottom side, right? They're going to have markers to indicate their little arrows that indicate the slope, right? So these are two kind of bent little arrows. So those are parallel to each other. If you see on top and bottom, we see just a single arrow, right? So the slope is different, right? It has a different brand, but because the top and bottom are the same, we know that those are parallel. And because sorry, I'm trying to pick my eraser here. And because the sides are there, that's a big one, right? So that's where the word parallel comes from with parallelogram. Opposite sides are also going to be equal in length, right? So this is important. So imagine kind of like a rectangle that kind of tilts, right? That's kind of what a parallelogram is, right? A rectangle, in fact, is a parallelogram as well, but not all parallelograms have 90-degree angles. We'll get to that in just a second. But we can see how the top and bottom and the left and right sides respectively have the same size. What goes along with that are a couple of other things. Opposite angles are going to be equal, right? So again, they're kind of diagonal from each other. So they're not next to each other, right? They're not neighboring angles. They're opposite angles. So those are going to be equal. So that's important. We're also going to see, again, you'll see these are congruent angles as well. They're going to be equal. Another thing is that adjacent angles are going to be supplementary, right? So angles that are next to each other will add to make 180. And that happens this way as well, right? So as long as the angles are next to each other, we can get that measurement. So that's another thing we know has to be true. The last thing we know is that the diagonals that run from the corners, those are going to intersect in a place that creates the diagonals will be bisected, right? So on either side of the intersection, you're going to see equal length segments, right? So we can see that here as well, right? So it's very there's a lot of balance to these, right? And so when we go look through problems, we're kind of looking for that balance, but we need to make sure that we can kind of address these different properties here. All right, so quite simply, if I were to make up a couple of links, I could go forward and kind of copy the rest of it. All right, so if I said, for instance, that this was 70 degrees, and I said that this was 15, let's say this is 10, okay? All right, so length of 10, and let's say this is 9, and this is 6, okay? All right, so these are the different parts that we can see. If I know these, I can fill in the rest. So I'll switch my color here just to kind of give you an idea of that is. I'll switch to red, or as red as I can make it. All right, so if this is 70, okay, then that means up here, this is going to be 110. Okay, so again, those two angles have to add up to make 180. Now the opposite of 70 will go over here, and then 110 will go over here, right? Because they're opposite angles. So we know as long as we have one angle, we can find the other four. We also know the side lengths, right? So the top side should be 15, and the right side should be 10, right? We know that that should be equal. Sorry, that I know that looks like a 16, but sometimes it gets a little sloppy here. 10. Okay, so we know that that has to be true as well because opposite sides have to be equal in length. And then when we look at the diagonals are going to be bisected, right? So that means each half of the diagonal will be the same length. So this will be 9 up here, and this will be 6 down here. All right, so we can see kind of how all this fills in. So if they give us partial information, we can kind of pull that and kind of figure out the rest. But again, the list of things we need to know about parallelograms was up in that very beginning part. So let's continue and look at some problems here. So can we show that this quadrilateral is a parallelogram? Well, the information that they give us are two angles here. We see 62 degrees and we see 117 degrees. If we add these together, we're going to get 179. So this is not 180, right? That's not what we expect. So this is a big no, right? That is not going to work, right? It has to be 180 next to each other, or else it's not going to have the sweet balance that we expect from a regular parallelogram here. Okay, so if we look at another problem, can we see if this is a parallelogram or not, right? So we see some equal lengths here, but you can even kind of tell this is kind of a little wider in places than the others. But what we're seeing here, this is not what we want to see, right? What we want to see are that these are equal, okay? And that's not the case. So this is again a no, right? We want the either side of the diagonals to equal the same size. This is proof that in fact it is not a parallelogram because we know if those are different sides, then it definitely doesn't work. So let's continue and let's look at maybe another type of problem that this can kind of apply to. Um, it says if BD is equal to 20x, so I'm going to go ahead and write this down here. Okay, and BF is equal to x plus 38. Find the value that makes this a parallelogram. Okay, so we know that this can be a parallelogram because we see that diagonal is broken into two even chunks. We can see that. We don't know the length, but we don't really need to. But the only way for this to be a parallelogram is going to be for these two sections to equal each other, right? So that has to be true also. So we're going to say x plus 38 is equal to 20x. So this is a two-step equation here. We're going to combine the x's together. The best thing to do would be to subtract x from both sides. This is going to give us 38 is equal to 19x. And then we can divide both sides by 19, sorry. And this is going to be 38 over 19 is going to be 2, and 19 over 19 would just be 1, right? So x equals 2 will make this work. And we could go back and plug this in as well. Up here at the top, 40 would equal 40, so x equals 2 makes sense in this problem. So again, we're just using the property of the parallelogram along with some basic algebra to kind of solve some problems where we don't have just numbers, we have algebraic expressions. One more example here. It says find the value of a that makes this quadrilateral a parallelogram. So again, opposite sides need to be equal, right? So this needs to be equal and this needs to be equal. All right, so hopefully we can just look at one pair of these and then that will copy over. It should copy over as long as we pick one. Whichever one makes the most sense for you, it doesn't really matter which pair. I'm going to pick the ones that I've underlined. So I'm going to say A plus 33 is going to equal to 11A plus 23. So this can be done over a couple of steps, but I'm just going to do one. I'm going to do one step to clean this up at first. So I'm going to subtract A. So I'll show you kind of why I'm doing it this way. I'm going to subtract A from both sides. It will remove it from here, and I'm going to get 10A on the right. Okay. Now, because I have my A's are consolidated on the right, I'm actually going to get rid of this 23 as well by subtracting it. That way, it consolidates all of the constants on one side. And so 33 minus 23 should just be 10. Again, I can divide both sides by 10. You can see that A should equal 1. Okay, so that works for that corner. So let's see if it works for the other side as well, right? 8A plus 8, that should be 8 plus 8, which is 16. And that should also be 16. So A equals 1 would be the solution here. Okay, so make sure to go back, look at those 5 properties that come along with a parallelogram, And then anytime you're in a situation, just like trying to merge those truths with whatever we're given in the problem is how we can go forward and show that something is a parallelogram.